This session is called Rise of the Machines, Virtual Machines in Support of Computer Science Courses. Presenting, we have Andrew Pullen and Andrew Miles.
Okay, thank you very much. So, called this session Rise of the Machines. So it's all about basically what we had to do with to deal with what was becoming a very overburdened lab infrastructure. And so it had become a necessity. We had to change our model somehow, and we'll get into all that. And the end result is we definitely achieved that, and we have more to do. But the biggest improvement, which really hadn't been on our radar at first, was the improvement in the experience for the students and even the faculty and the IT staff on our end. So it was great overall. This is briefly looking at how we're going to go through things. Andrew Miles, who's been in computer science for many years, is going to give a bit of background information on the sort of context of where we were and what prompted us to finally dive in and start official VM support on our desktops. And then I'm going to sort of take you through how it evolved, and a lot of it's fairly basic, but it's just meant to show what our mindset was and the types of problems we came up with and how they were addressed. And a lot of things you would think, oh, well, that logically should have been done first. And so it just sort of shows how the whole thing evolved. We'll give a summary of what worked, what didn't, and what we might do differently. And then there's a few random hints for anyone who hasn't touched VMs much before, just some things to keep in mind. So, and then of course, we're hoping to hear some questions and whatever other people are doing. So I will pass it off to Andrew Miles for a bit of background.
Okay, hi. So I'll give you a bit of background about our infrastructure. I saw a lot of presentations over the last couple of days, and a lot of them looked at the entire university as a whole. Well, that's not really what we are. We're not even at the faculty level. We're the School of Computer Science. So we're at a smaller scale. We have 4 technical staff in our school. We have 200 Windows lab PCs, so we're not a very small school. We have medium-sized needs. We have 16 Linux server PCs, about 30 faculty members that we take care of, and we have 6 student computer labs, and we run all sorts of servers that we use to support our courses at the school. Okay, so what happens during the term is a number of professors come. They would like us to support their courses, so they want to leverage what the school has to offer. So we get all sorts of requests, like programming and software, which is obvious for the School of Computer Science. They have database courses that we need to support, parallel computing, sometimes GPU computing, kernel development, web programming, and students like our user homepages and email. So we need to support all this now. How are we going to do that? Well, this is basically what we've done with we've been running this kind of setup for about a decade now. Basically, we take a bunch of Linux servers, put them in our server room. They connect to those remotely through our Windows labs. So down here, so we have 200 Windows labs. Student logs into the Windows lab, and they can connect to these Linux servers remotely. Now, the database courses, obviously, we need to manage a database server. The parallel computing can be done on the Linux cluster that we have here. The GPU computing, well, we have to reserve a number of computers with GPU cards, so we have those their own space in our server room. Kernel development, now this is an interesting one. Well, they require root access. Well, we can't put them in our Linux servers because they'll crash those pretty fast. So what do we do with those people? They need root access. Well, we basically give them their own lab. We cut them off from the internet, and they can do whatever they want there. What typically happens, we ghost a machine for them. They do their kernel development, and typically somebody will screw up a machine, mess it up to the point where it just won't run anymore. Then you have to go in there, clone the lab, or clone that machine. And so it's a little bit of a problematic case. What do you do with kernel development? It's a beast in itself. Web programming, of course, we need a web server, user homepages and email that we can take care of pretty easily. So that's kind of our current infrastructure and how we set things up. So I'll give you now like a problematic case. So So I'm going to describe all sorts of problems, and we'll see how virtual machines can solve a lot of these issues. So here's how people access our Linux servers. So here on the right-hand side, we've got our Windows labs. We've got 3 users in our Windows labs. They log in remotely to our Linux servers. So they get full X11 desktops. So what happens if we have 15 users? Well, okay, 15 users in our labs. 5 of them like the first machine. So they all, for some reason, like the first machine. They all log into the first machine. One person on that machine runs a load that's very high, bogs down the machine, and obviously affects everybody else on the machine. So we've got 5 angry users in the lab somewhere because that machine has been bogged down. Also, you can see that the network, these thicker lines mean that the network requirements for full X11 desktop to our Linux server starts to increase the more users there are, particularly to the switch that goes to our Linux lab. So that's the weak link in this case. So now if you ramp this up to, say, 50 users, well, depending what kind of switch you have there, and in our case, we don't have a big budget. These machines are a lot of hand-me-down machines, older switches. Well, the bottleneck is going to be this switch right here, going to the Linux server lab. If you have a lot of users doing computational intensive things, this is going to be your bottleneck. If that happens, of course, everybody in the lab is not happy. Also, load on these servers starts to be a problem as well. So that's some of the problems with running a Linux cluster. Now, database courses are an entirely different beast. Now, how do you support a database course? Well, the way it's done right now is that we require the students to log, like we have a bunch of static database servers. The students need to log in some manner. So we have about a number of account management scripts that we set up with our account management system, particularly just for the database students. So that takes quite a bit of setup. It's a one-time setup. So these students create their accounts. It sets up the database accounts for them. And once you have that set up, that infrastructure set up, that's a one-time thing. Now, what changes term by term is one professor will want Oracle version, so and so and so and so, but you don't have exactly that version. But all his scripts run on that version of Oracle. So you basically have to, every term, set up a new database for every particular professor teaching the course. So this is something that you have to do every term, and that, again, takes some sort of expertise, quite a bit of expertise to set up. So you can see there are a number of issues here as a system administrator to manage this type of network. So some of the problems we have, well, network bottlenecks, network bandwidth problems, loads on the servers, load balancing is an issue. Users do not have root privileges. Network administrator has to install software, limited database administration, and some of the ongoing issues that we have is the updating of software. We have limited number of Linux servers, providing a remote desktop, so full X11 experience, and systems administration is always, I mean, our time is, we don't only support some of these courses, we do a lot of other things, so that's limited. So, to the rescue come the virtual machines.
Okay, so just to recap, the biggest issue that was on our mind during this period when we started to get into VMs a couple years ago was the Linux issue. This was what was painful. Most of our courses were using this, and every single term, more and more faculty wanted their students using the actual X11 desktop. They wanted students to realize there is an OS other than Windows and Mac that they can use a desktop on. especially with the early entry-level courses. So that was the painful thing. The problem was because there were so many courses, we realized it was going to be a huge scope of project, and we didn't have a lot of time. And we just we tossed around the VM ideas, but it just didn't happen. So we put our energy into a little better switch and some better network cards for the machines and minor upgrades like that, and just tried to survive. It was actually the database one that presented the opportunity to dive into this space. So just supporting every term a different flavor just started to get a bit frustrating. Having to integrate that setup process, you have to set up databases for each student, tables for each student, all the access control, the grant permissions, all that stuff needed to be done every term, and every single database has its own administrative way of doing that. Like some of it boiled down to simple SQL, but not everything. So finally we decided, you know what, it's a fairly small scope. We're talking about 1 or 2 courses, so if we blow it, it's not the end of the world. We'll give it a shot on the VMs. So first of all, we looked at it. Is this actually going to save us time? Because otherwise it's not really no point. So we have to set up that database server anyway. So whether we do it in a VM or on that central server, it's still going to require time. The big savings was not having to worry about these scripts anymore. And then there was also the added bonus of students often only went in to do the account update procedure because of the database course. Usually once they had created their accounts and had generated their Mac accounts, their Linux account, Windows accounts, they might only have to do that once during their entire 4-year term, except if they were doing database courses. They'd have to run the procedure again to do the database setup. So that saved both for the students, and it reduced the number of tech support to us, students coming along for that. So it was basically, let's get rid of this whole thing. And we definitely decided, yep, this is worth giving a shot. So the first model was a virtual machine. We started with WinXP just briefly because the faculty wanted it and we had access to our XP licenses. We just locked it down a bit. Now basically everything's Linux. VirtualBox was used, and I'll get into why we use that in a little bit. In this case, it was basically we created an appliance file, which is just an export of the VM, and the students would import that both in the labs or on their own. And that was simply a convenience thing for us at the time. We didn't have enough time to integrate it into the image and the mandatory profile. So this was a quick solution. You just pop out the OVA files and have a quick little batch script to import it into VirtualBox. And then obviously the students take it home. That was one of the primary things we wanted. So just diving into some of the benefits. The big one, definitely students didn't have to worry about updating that account every term. They just have a generic account that they can do all their stuff on. They could have multiple databases for the first time. That was something we'd never offered on our centralized service before. So they could do a bit more complex work. They had full control over those databases and tables if they wanted to change things. They had control over the OS. A lot of them, they would like to install their own editor, like a client for SQL. It was nice that they were now insulated from crashes. Every once in a while, no matter how robust Oracle is, someone would find a way to bring that server down. And then you'd have everyone in those classes freaking out. And of course, that means they have to come find us. And usually we only respond at 8:30 in the morning, not 3 o'clock in the morning, which is when they're typically doing their assignment. So it was much easier. All they have to do is reload the VM. Or if they're smart, they have a snapshot from an earlier state and they just reload their snapshot. So they're back in action 10 seconds later. So some things, we knew all this was coming because we were using VMs, but some of the things that we didn't anticipate was we could really customize it for the instructor and add little things like quick links to how-to documents and stuff like that on the desktop. The students were using their own computers. We didn't realize how many of them were going to start doing it because most of the database courses, it was a lot of lab usage. And it was nice with the quick OS updates. It didn't always save time, but there's those scenarios when you need to update a database server, especially if there's 3 courses using it that term, you'd have to schedule downtime and notify students and all that so you could perform the upgrades. With this, we just pushed out a new OVA file and the students just had to download it to their computer if they had it there. So it was pretty easy. Some of the problems, because of our model of just having the machine, obviously it took a few minutes to import that. Our images got up to like a gig at some point. So They needed to understand that because they had a mandatory profile, when they log out of that machine, that import's gone. It disappears. So they need to save, if they do want to save like their SQL code or something, they've got to put it on a USB or a network share or something. Obviously, we ran into some license restrictions, like there were scenarios where we couldn't use certain database software because it does not allow you to install it on a VM. It's a one-time central server only type deal. At first, we had a networking issue. Obviously, that's not an issue with the centralized server, but in the VM, faculty member said everything was okay, and then a month after we had deployed it said, oh yeah, by the way, did I mention we were going to be doing transactions this year? So we need network access. Like, thanks for telling us now. So there is a bit of a learning curve. It's just it's not like just being logged into the Windows machine. So obviously they had to understand that what they're doing. So we usually had a nice how-to about what VMs are. A lot of these students were brand new students, so to computer science, and they hadn't played with VMs before. And there could be some headaches if we had to deploy 200 new VMs to all of our lab machines on short notice for a course starting the next morning. You still had to push out a gig file everywhere, and even with Ghost and stuff, it was a bit of an issue. So that was the database. After we had that working, we're like, okay, you know what? Maybe it's time to actually look at the Linux VM solution. We still had all those users freaking out, and it was getting worse and worse. The term that we decided to give this a try, we actually had a faculty member come along and said, I have 200 students in my course, and one of my assignments requires them to have 5 simultaneous applications running for their peer-to-peer application, and I want them all on a desktop and running on our Linux servers, by the way. So we had 20 servers to share, and she wanted 1,000 X11 sessions simultaneously. Like, what? So anyway, that wasn't going to work. So we decided, you know what, let's give this a try now. We have the basic infrastructure in place. Let's see where we can go with it. So the goals, we now need hundreds of hosts, not 16 hosts. It needs to be completely distributed, completely customizable to each prof. We want a VM for every course. No more of this jamming, 140 different applications onto our Windows image and a similar number onto our Ubuntu image running on the servers. We want just a stripped down version with what the course needs. Disaster proof, just like the other VM. Get back in action super fast with those snapshots. Take it home. This was a big issue. One of the biggest thing, if you talk to any of your comp-sci or engineering profs, is student compiles an assignment. It's like an hour before it's due at midnight. Everything works fine. They submit it. TA tells them the next day, oh yeah, I gave you a 0 because I couldn't compile it. It's like, and they just had their own installation at home. It was missing a library or something like that. This is one of the biggest faculty complaints, is finding ways to solve that problem. Now it's easy. We give you the VM. The TA is using the same VM. As long as you make sure you keep a snapshot of that initial state that the TA is using and it compiles, the odds are it's going to work on the other end because it's exactly the same. And oh, by the way, we had to do all this for free because we don't spend money on anything ever. So, ever. No problem, right? So here we go. Basic model is going to be Ubuntu was the base this time. VirtualBox used again. Students are going to have full admin privileges. This time it was deployed hot in VirtualBox, so it was part of the mandatory profile. They go in and it appears in VirtualBox under the mandatory profile. There's VMs for each course. It made it a little more difficult to push out the VMs because we actually had to dive into the mandatory profile on each computer and do some config changes to get the new VMs to show up. But we figured out those bugs, and again, students had to take it home. So this is just showing the sort of evolution of how things changed. It's all basic stuff, but it's a bit of a nice story, I guess. First one was just a simple Linux VM, just for one course, was deployed hot. We had our 200 hosts, all was happy, and the students could download it. So nothing special, was just for a generic programming course, a Java course, I think. So the next model was when that faculty member who did want to be able to run those 1,000 simultaneous desktops, well, we basically set it up so they would quickly be able to boot up 5 versions of the VM, and they would have a little virtual network, and they could do their peer-to-peer testing in there. So easy enough. So that was, again, on a single host machine. So from there, the logical thing is, okay, we want to be able to get at our files easily. So students wanted to use Dropbox because they all want to use Dropbox. So we installed Dropbox on these machines. For our poor networking course, it was a bit of a problem because they'd have to sync each one, so it was complicated. So that led to the next quick change where like, okay, well, let's just, one will be an NFS server, and then all the rest will just grab that. So just boot up the NFS first, and the others get it, and you just have to sync that one. And then we started using our brain and realized, you know what, they already have network shares and everything on the host. Why aren't we just mounting that directly? And before we're thinking more isolated from the host itself, but we're like, that's not a big issue. Let's just give them access to their file server. And that problem went away. So they just kept everything on their Z drive. And then for the number crunching courses that had massive data files, we had a big space available to the host on the D drive. So now, naturally, that networking course then decided, okay, well, you know what? We want all of the students, not just on a host machine, but I want their peer-to-peer stuff to be able to work with their partners in the other computer labs. So they'd have to be able to access that. And of course, a lot of those students can't get in. They're at home. They can't meet at the same time as the rest of the guys in the group. So it's got to be open to the internet. So that opens up the problem. Okay, well, we were sort of hoping to limit that network. So what we did was the network is being accessed through the IP of the host, and we simply have the firewall configurations to pass it off to VirtualBox, which sends it down on these particular ports. So, and that was easy enough. And this is the model sort of that we're using today, and it's been able to handle most of the scenarios that have come up. So, why they worked. I wanted to, basically I'm showing the database VM and the general Linux VM here, and it's because I just want to show that there's so many different scenarios, as you've seen from all the talks on VM and VDI and everything else during this conference. There's so many different scenarios that can be solved by this. So, and there's so many different benefits to be garnered. So course specific, yep, that was a big issue for both of them. We could be very specific to courses. It saved time on the database one. We saved a lot of time. On the Linux one, no, that wasn't part of the game. We knew we were going to be spending more time because now we're supporting VMs for every course. It wasn't going to get, like we still have to support lab images. That's not going to change. We still have to support our core Unix machines. None of that went away. That wasn't the goal here. So, but we felt it was going to be worth it, and it definitely was. Student customizable, the database course didn't really care about that because they're just running SQL and basic transaction. The Linux VM, that was a huge issue. They need to be able to do kernel development. So this is what they were really looking for. The user experience definitely improved on both of them. It wasn't a big issue for the database people. Increased seat count, again, the databases were a centralized server before, so there was no real seat count issue per se. For the Linux VMs, overnight, we had a factor of 10 increase in the number of seats. So this was huge. I can't understate that enough. It wasn't a big issue with the database courses again, because SQL is SQL is SQL. But with the Linux VMs, the number of profs who just said that problem went away overnight, and they just could not stop thanking us for that. The being distributed, huge benefit across the board, quick recovery from those snapshots, et cetera. Having a safe virtual network was great. Getting rid of the headaches for the networking. The networking courses would say, you do not test your thing outside of the VM network until you know it works, and then you can bombard the real network with it. So, and their friends would get mad at them if they did things that caused problems. And yep, it was free. The whole thing, other than our time, of course, all this took time. So obviously it was something new to learn. So this is one of the, what we call it detriments, but it's not really a detriment, it's just part of the game. So it was a big issue with the Linux VMs. There's a lot of shifts here. We were given a lot of capabilities to the students now that they didn't have before. There's some import-export time issues, like it would take some time for that. The networking restrictions wasn't an issue with the database course, but it's been a bit of an issue with the Linux courses because we have had a couple of faculty using networking software that it was proprietary, sort of locked down. We couldn't change the port to the 60,000 range that we had opened up. So we ran into some issues there that we sort of had to figure our way around. This is important, limiting the VMs to 32-bit. And we didn't do that at first, and that bit us because, unbeknownst to us, even though most of the students have 64-bit processors, those cheap little netbooks don't have virtualization support on those processors. The low-end AMD and Intel And there's actually huge numbers of our students coming in without the capability of running a typical 64-bit VM. There were some deployment headaches just having to push out those images and learn that whole procedure. There's licenses haven't been a big issue because most of the software we use doesn't use licenses. And of course, free was a problem. Why was free a problem? Well, it would have been nice to have been able to spend $100,000 on new servers and do like a VDI, VCL type solution or whatever. But no, there was no money, so we had to just use that lab that was there. So, but the benefits definitely outweighed all these issues. So, what are they used for today? Still, database VM is basic SQL and transaction processing courses. The Linux VM, programming, algorithms, OSs, the networking, pretty much all the courses get the students to test in the sort of VM safe mode now. And recently, app development, a lot of the Android development's now happening on that. So we sort of did a bit of brainstorming about other scenarios this model might work for. Obviously, if you're doing a one-off, someone coming in, borrowing your lab, software with old OS requirements, we have scenarios where really old OSs are needed. So obviously, any virtual solution, that's the way to go. And scenarios where you sort of need to breach your network for certain reasons, or your security, where you have to run an application that's doing things you don't necessarily want. It might be nice to sandbox that into a VM. Places where it doesn't work that well yet, game development and GPU, which are both big things at Carleton SCS. Most of the virtualization solutions do allow you access down there, but it's not great yet, and it's not perfect, and it's buggy, and most of the faculty have tried it out and decided that they can't get it working quite the way they want it. And but it's coming. It's obvious it's going to be there. So, and then obviously the restrictive license issue is basically either stick to the old model or find new software, which many faculty don't like hearing that. So, for some reason. Was it worth it? For sure. We have 5 specific course VMs plus a number of faculty designed VMs that we've deployed. And most of the courses use it at some point, especially during tutorials. Almost every course uses it in our tutorial labs, our basic VM, Ubuntu VM. The biggest issue with students is this. And that's the biggest feedback that all the faculty have received. And that's the biggest feedback the faculty give us. It made that problem evaporate, and that is one of the biggest time-consuming problems for faculty during the term. And just getting that assignment issue out of the way. And then obviously the students love this, being able to just drop back to a sandbox. And a lot of this seems obvious, but for an entry-level computer science student who haven't used VMs, they have no idea about things like snapshotting something. The fact that we have the procedure, we have the help documentation, and the faculty now takes them through that in the first intro to the course, it just sort of puts them in the spot where they understand that, and then like everyone starts doing everything's on a VM. Like no one uses their original desktop anymore. So, and I think that's great for the comp sci students. Few random hints. Definitely look out for that 32-bit VM issue until that goes away, hopefully soon. Because how long can they keep shutting off that VTX technology, right? It can't save them that much money. This was a big thing. Put a generic admin account and a generic student account on every one of your VMs. Even if the faculty member wants one with a specific username and password, like a lot of our faculty use the same username and password used for their content management system just to keep it consistent. But if you do this, then any course or any student that needs a specific VM for a reason, they don't have to go and try to find on the web where that password is or ask someone. It's the same for every single VM we ever deploy. And even the faculty members, we won't deploy their VM to our labs unless they agree to let us put an account on it, this generic account, or these 2 generic accounts. Obviously, get the faculty and the instructors to sign off on your VM before you put it out. You do that for all of your software, so hopefully that's a no-brainer, but it can bite you in the butt. So, and create some nice generic how-to documents to share with the faculty, because if you rely on just the faculty to do it, you'll get a lot of inconsistencies between things, and some faculty will just forget about it, and the students will be like, I haven't used a VM before. Like, I'm just coming in, I'm a first-year comp sci student, and so. And why do we use VirtualBox? Well, it was free. We had a lot of experience using it. We love VBox Manage because, like with scripts, remote scripts, you can do anything you want. It's really granular control. And we did run into some earlier issues with VM Player. But ultimately, VMware is free for ComSci students, so that's not an issue. So that went away. And a lot of the students were using VMware. We have it in our labs, but we haven't been using it because we have the VirtualBox stuff integrated into our image and into all of our batch scripts. But we can easily go to VMware if we decide we want to. And like I said, a lot of students used it because they have it anyway. It's free. So, and then VMware, if this really goes large scale and we start to want to do more interesting things for deployment, having the sort of really effective and enterprise level management that VMware type solutions give will be a bonus. This is just sort of building a VM. The point is, try to work with all your instructors and do a good base installation that can be shared to minimize the amount of specialization you do for each course. And I didn't talk about it much, but the reason why we specialize for each course is because when we were getting up to 140, 150 software packages, you were starting to run into a lot of conflicts. On the Ubuntu machines, we're running like maybe 7 or 8 different libraries of Python. So the students had to know exactly which Python library to load for their course. With this, that goes away. That course only has one VM, and that VM has that Python. So they didn't have to worry about, okay, when I'm linking this, I'm using Python 2.7 point whatever, or Python core, and we put a course reference or something, so they knew it was there. So that went away. And get your TAs to test it. Don't just rely on the faculty to test it. The TAs are often the ones who are regularly dealing with the assignment. So if you can get them to do it, that's great. And test it after you deployed it. Don't just trust that it's going to work once it's out there. And that's pretty much it. So we'll open up the floor at this point. Thank you very much.
Questions?
You made the comment that VMware was free to your students. Is that because you're teaching VMware? Do you have a license for it?
Yeah, we have an agreement with VMware, that it's made available to ComSci students because we do, like some of the courses do a bit of development with VMware, like on top of the VMware API, like it's just part of the virtualization. So I guess that faculty member got a deal for. It's sort of like, it's the same as DreamSpark, except in fact, the people who run DreamSpark are the ones who run this for VMware as well. Right. So, and...
So it's free for 1 year.
Yeah. 2 years for us.
Yeah, we have 2 years. So, well, the life of your thing, and then you download it at the end, you get 2 more years. And that's why we did stick with VirtualBox for sure, because VirtualBox will hopefully live forever. So we'll see what Oracle decides to do with it. But rumor is Apache's will take it over if Oracle decides to kill it. But yep. Oh, sorry. Sorry, I thought I saw your hand.
Did you have any network issues when you set it up with regards to congestion? You upgraded some of your switches, that I understood, but wasn't really any issue after that, was it? Or?
Yeah, no, the biggest networking consumer was the X11 session on the remote servers. And when she took that away, all that is running on the host now. So it was just really the networking. The networking courses were the ones that would do the damage. They wouldn't test it thoroughly enough on the virtual network, and then they tried on the real network, and they just flood the entire channel with whatever they were doing. So, and of course, by the nature of what they're doing, we had to just, like, those ports have to be open, like under all circumstances. So, yep.
So just for like an average user experience, say you come into the lab, they log in, the domain credentials, VirtualBox opens up, or they open it, and they see listed all VMs available, or are you restricting some based on course?
We don't restrict based on course. Yeah, they're all there, and that's one of the things that we want, is that any student can use any VM, and so that they can see what's going on in other courses if they want to. So we're trying to keep it very open. Obviously, if we got into a scenario where we had permission to use a proprietary software and it was restricted to that course, that's a scenario where we will have to lock it down. So, but we haven't come across that yet. So
you haven't really developed a implant that? You just-
Not per se. Well, with the VBox managed scripts, it is fairly easy for us to run a script on login that checks what groups they're in, and then we can just pull an option out of that list. Now, ultimately, we might have to play with permissions on the actual VMs themselves, because they could, if they know where to find them on the in the directory structure, they just go and import it into VirtualBox themselves. So we'll have to deal with some more granular issues. I guess it depends on how hard the software company wants us to protect it. So, but yep.
If you're making a new VM for each course, are you sort of installing fresh each time, or do you have base images that you copy and modify?
We do that base. So we have a base Ubuntu that we sort of got together with most of the faculty using it and agreed on a number of packages that everyone thought would be useful for a basic programming, like some good editors like Vim and Emacs, and a few common libraries like GCC libraries and ncurses and stuff like that almost all of them use. And that became our base. And then we'd specialize for individuals, like adding specific Android stuff in Eclipse or whatever. So, yep.
Were you relying primarily on faculty to disseminate information about how the VMs would work? You indicated you had some documentation, but I mean, you also didn't indicate that your students were having great issues. So was it faculty members just making sure users were clear, no way on the VM, or were you directly interfacing with those?
We interfaced a little bit. We put our how-to documentation on the website, but the faculty put it in their course outlines typically, and it was done. They'd show them. Usually it was the TA would give a quick demo of it. And for most of them, as long as the first year course was doing it, like that had almost every student in 2005 doing Java programming, then they'd see it at that point, and then they knew what to do. So they really just had to be given a link to the VM. And from our perspective, it was usually if they ran into a problem setting up VirtualBox or VMware that the TA or the faculty member couldn't deal with, and they might send them to us to help out. So
a lot of the courses also have tutorials. So during a tutorial, that kind of thing would be done. Show them how to access the.
Oh yeah, and I didn't mention that, but I actually was invited. I went to quite a few tutorials early on and presented, like did a quick overview of it myself, since I was doing it all the time.
So you commented about students' computers and some of them not being able to run the 64-bit environments. Do you provide any computer lab computers at all? Or
Yeah, those 200 Windows machines in our Windows labs are the default place to go. So, and in scenarios where we've had students who just could not get a VM solution working for whatever reason, that was the fallback. It's like you're just going to have to go and do it in the labs like you normally would have to do. So, and it was nice. The labs are still reasonably heavily used, but it definitely took a bit of a load off. Like if it was really busy, student wasn't out of luck standing up waiting for a computer, as it used to be the case. They would just go and say, you know what, I really need to do this. Can you give me 2 minutes to download the VM off the D drive or whatever, and they could grab the VM from there and import it themselves. So, or they could get it off the website. So depending on their connection. So
are they running with their own computers? Are they running the actual VM on their hardware? Or?
Yeah.
Okay, so they're downloading.
Yeah, this isn't a virtual like a VDI or a remote desktop type solution. They're actually
providing the image. They run the image on their hardware, and then they have the environment to do what they want.
Yeah, and that's the thing. We just didn't have the infrastructure to have a remote connect in above and beyond our Linux servers that had already been doing that for years. So.
Are the changes made to the virtual machine in your lab? Like if they use it, do their homework, do a snapshot, let's say, log out, someone else comes in, do they pick up the snapshot?
Yeah. I didn't even talk about that, but that was why we integrated it into our mandatory profile. And we actually locked down all the VMs, all their files, the XML file with all the specs and the actual hard drive. And when you set it up as basically a differential disk, that locks the initial image itself. And then what you do is you allow all users access to just the snapshots folder. And that's where any VM solution like VMware or VirtualBox, any changes you make to the hard drive after it's been locked, gets saved in the snapshots folder. And because all students have access to that, it appears there. What happens is when you log out, it's a mandatory profile. All that magically disappears. So, and that's why it was important to educate the students on save your stuff on the Z drive, on the network share. Don't just leave it on the desktop of that VM because it's not going to be there. So, and one of the things we thought about is maybe we should be mapping the desktops directly to the Z share, and we'll probably look into that for a future version. But that's how we locked it down. That was important because we couldn't risk a student sitting down and breaking a VM accidentally or maliciously and going to every single machine and repeating the exact same process. So we would actually create that lock file, and VirtualBox and VMware, they all support that, where you sort of lock a disk, and then all changes beyond that point are done in a snapshots folder, as it's called. So, yep.
How do you work version control? So student year 1 downloads the box into their hard drive, and then year 2 the image changes, so they have to go back year 2 and get the new image.
Yeah, typically that's the model. So that's the official model. A lot of the students will just update their VM because they're good Linux users. They know what to do. But we always say the caveat is, if you want to be able to argue an assignment issue, you have to have done it on, like, downloaded the most recent copy of the VM and run it there, like the one that the faculty says this is the one the TAs are going to be using. So if you're not doing that, then you're sort of out of luck. So the only problem is we don't have any way of verifying that, but we've never had the problem. We've never had an assignment yet that a student compiled it on their own version of the VM and it didn't work, other than potentially networking issues, which you just open a port and that problem goes away. But so, and obviously for the future, we'd like to see some to integrate things like a virtual lab, like VCL type stuff that Carleton's sort of playing with now, and the VDI type things. Like, all this can work together. Like, all these images can be the same thing, like whether we're deploying it to our Windows lab in this type of scenario, or whether it's a remote, go out and grab a VDI session or a VCL session from a remote server. It was just, we have no money for that type of stuff right now. So, but if the university decides to do a VCL lab, like, which we're talking about and we're actually working on, we're definitely going to have our image there front and center available, just so it provides another option for students to connect to it. So obviously we'll have to play around a bit to integrate into their user space on the central computing systems servers, but that's fairly minor changes, hopefully. So.